Capacitors are connected as shown in figure. Calculate the equivalent capacitance between the points X and Y. So this type of problems is just a simplification of circuit. So by seeing the connections, here we can see the three capacitors they connected, but the connections are something weird. So from here to it is went up to at here, and from the B to from it came up to there. So here we need to simplify very easily. So that is the first our task. Now you carefully follow the connection point. Suppose this is the A point. It means this plate also gets A, and the same A point is carrying up to at here. So here also it will get the A point. I should not draw the arrow marks, but to make you understand. So this capacitance also get the A point, and this capacitance also get A point. Now from A point, three capacitance plates are connected. Now I will redraw the circuit in below. So first plate and second plate and third plate. Why did I draw parallelly? So because from A point each capacitor should get from A point. So if I take this as A point, so this is my A point. So from A point I can connect from the one of the plate to the capacitor. From same A point I can get another plate, and some same point I can get the another plate. Since from A point each plate got separately, that's why we need to draw in parallel. Now we analyze about B point. Now this is the B point. Now the B point is went all the way. Before that, B point is connected at here. So that is B point, and it went all up to there, and it went up to here. Since it is junction, it is connected, and it is also connected to there. Now here the B point is also connected to three plates. Suppose if I draw that as B point for a capacitor, so this is another plate of a capacitor. Now I need to take at here B point. Suppose this is my B point of a capacitor. Now we need to connect that B point separately. So from this and here and finally at here. Now the given circuit has changed something to known circuit, we know it. So now these three capacitance of capacitance C, they are connected in parallel. So what is equivalent capacitance between A and C? The equivalent capacitance, since it is in a parallel, so 1 C equal to equivalent capacitance C equal to C plus C plus C. So equivalent capacitance equal to 3C. So the circuit after simplification, so it came to our known circuit. So this is how to simplify the circuit. Let's change to another complicated little complication. So we will analyze this problem. So the problem is the capacitors are connected as shown in figure. Calculate the equivalent capacitance. The equivalent capacitance of the given circuit we need to calculate. Now here as usual, first you take the A point. So the A point is going all the way. So like that it is going. First you can put it at here, since it is connected to A point. So this goes to A point, and it is also goes to A point. Now I understood that from A point two plates are connected in parallel. So I will draw that first. So one capacitor is there. So it's supposed to connect it to from a point, and another capacitor is there, it is also supposed to connect to a point. Suppose if I take a point at here, now one capacitor plate I will connect it to a point, and another capacitor plate I will connect to as an a point. Now this is point A, so these two are connected. Now let's see B point. Now B point right at here, the green arrow mark false. Now the B point is connected to one of the A point, so final capacitor, and another capacitor at here. Sorry, here it is B. Now the B should connect to one of the A. Now if I take this as at here, now I will draw one capacitance plate at here, and this capacitance plate I connected to one of the B point, and another B point we need to connect at here. And before that, if you can see, so this capacitance plate already connected, so this capacitance plate is nothing but this is the one I already connected, and we need to connect the rest of the three capacitors. And the first capacitance plates, this is the I already connected at here. Now if I can connect the rest of the ones, since the rest of the ones they do not connect as in any B point, since the rest of the three are in series by itself. So now if I draw that at here, one capacitor and another capacitor and final capacitor, now they are connected to as in a B point. Now if I draw this is in a more clearly, so the bottom three are in parallel to a 2 points A and the B, and from it here one series capacitor is there, sorry, one parallel capacitor is there. Now this circuit is equivalent to this circuit. How did we connect? Just the analyzation, rearrangement of the capacitors. So you can follow the pointing connections and junctions at the proper manner. Now here it is easy to find out since they all are having equivalent capacitance C. So it's a C, it is all C, C, C. So now it's easy to find out the equivalent capacitance. So now these three are in series. If these three are in series, we can find out the equivalent capacitance. 1 over C equal to 1 by C plus 1 by C plus 1 by C. So 1 by C equal to C equivalence, I supposed to write, equal to 3 by C. So C equivalence equal to, now here you can get C upon 3. Now we can replace that C equivalent with this parallel combination. Now if we can redraw that circuit, so one is parallel and another one is also parallel, and they both are connected at 2 points A and B, and this capacitance is C and this capacitance is C by 3. Now therefore they both are in parallel. So in parallel combination, what is the total capacitance? The total capacitance C equal to C plus C by 3. So you can get C equal to 4C by 3. So the equivalent capacitance, the above circuit, the equivalent capacitance of this total circuit between A by 3 equal to 4/3 of C. So this is how we used to change the given circuit into our known. So how do you follow? That's only the matters. How the connections are the made from one point to another point. If you can, just like opening hmm, a body, we should do it very carefully. Now let me take as a general example in this case. For capacitors connected as shown in figure, calculate the equivalent capacitance between the points x and y. Now I need to bother about the circuit. Now I need to simplify the circuit. Sorry. First let me simplify this is given circuit. It's missing 2 microfarad. Now just how we followed earlier, so like that we can give it the points. So let me take another color, sorry, to make easy. Now this is a point. Now the a point, it means here also it will be reaches to a point. So this is the a point. Let me take the black, it is opposite to the color set here. Yeah, so this is the a connection. So a connection is going up to here. Now the same a point is going at this junction, and this capacitors also having a, and this capacitors also having a. It means from a point 3 capacitors are going separately, connecting separately. So I will draw that first. So I will take the 3 capacitors, 1 2 3. Now they are connected separately to a point. That's it. Now let's see about B point. Now this is the B. Now the B point is also connected at here, 1, and the B point is also connected at here, which is also connected one of the A, and the B point is all the way coming at here at this junction, and that the same B point is connected at here and at here. Now here we can see B point separately connecting 4. So where the 3 A points are there, that next to B point is connected. So here also it will be B. Now I understood from this here. So this capacitance also connected to B, and this connected to B to a point B point. 1 2 3. Okay. Now this the B point which already connected to one more capacitance. See here you can see the last one which is connected separately. One side of the plate connected to B point, another side is connected as an Y. It means suppose if I draw at here one capacitance plate and another is connected to Y. Now this is the B point. Now at here we can extend that as an X. Now here it is X, X is itself only A. Now the above circuit is simplified as, now this is the 2 microfarad, and this is the 3 microfarad, and this is 5 microfarad, and which is connected to as a 10 microfarad. Now if you simplify this circuit, you will find the equivalent capacitance of these three, the equivalent capacitance of a parallel plate capacitor. Now if we can take that equivalent capacitance, how much I can get? C equivalence equal to 2 microfarad plus 3 microfarad plus 5 microfarad. So C equivalence equal to 10 microfarad. Now that 10 microfarad is again in series. Suppose if I draw the circuit diagram for that one. So 110 microfarad is in series with 110 microfarad. So between the 2 points, this is an X and this is Y. Now we find out the equivalent capacitance. So 1 over C equivalence equal to 1 over 10 plus 1 over 10 which equal to 2 over 10 which equal to 1 over 5. So C equivalence equal to 5 microfarad. So this is the final equivalence capacitance of the given circuit. So this combination tells how we can reduce the circuits to known combinations. Don't afraid by seeing that connections at all. So because they all are the after analyzing them, so the connecting points where they are going and how we can make it separately. So if we are good at that, so these kind of the problems are very easy.